Good morning. I want to take a few minutes and review some electron configuration that we learned earlier in the year. We want to spend this last week of school going over just a little bit in addition to what you learned earlier. It's going to be important, especially for those of you taking AP chemistry. So, start with a quick review. Earlier in the year, before we started doing bonding and writing formulas and compounds, we took a simple look at the structure of the atom, and we used a model similar to the one I have right here. So, in this model, which is often called a Bohr model or a modified Bohr model, we have a nucleus, and in that nucleus, which is represented by just a dark circle, are where the protons and neutrons are located, and those are extremely dense particles all packed together. So most of the mass of an atom, of course, is in that nucleus. And then an area around it, or a volume around that nucleus, space, if you want to call it that, has electrons in it, and those electrons move about that nucleus. Of course, we already know that the protons are positively charged, the neutrons have no charge, and the electrons have a negative charge, often symbolized with these symbols. And in a neutral atom, the positive protons equal the negative electrons. So in hydrogen, you would have one proton, one electron. So let's take a closer look at these electrons on what we learned earlier in the year. To do that, we're just going to draw an atom that has 18 electrons, and that's as far as I'm going to expect you to go, is the first 18 elements, and being able to draw and explain where the electrons are at in those elements or those atoms. So as you know, we define the distance from the nucleus in terms of energy levels. So the first energy level is the closest electrons to the nucleus. And this area around the nucleus we call the first energy level can hold a maximum of 2 electrons. So I drew 2 electrons in that atom. So this would be an atom showing 2 electrons and showing the first energy level. So here's that same first energy level with 2 electrons in it. I drew a circle around it or a line around it to separate it from the next energy level, which of course we call the second energy level. The second energy level can hold up to 8 electrons. 2 of the electrons, and I think I drew this one and this one, are a little bit closer than the other 6. So 2 close and then 6 a little further away. And those are the electrons in the second energy level. So right now I have an atom that has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. So if we were keeping track of that, it would be neon. So if I wanted to draw a very simple model of neon without showing the protons and neutrons, I could show a nucleus, 2 electrons close in the first energy level, 8 total electrons in the next or second energy level with 2 a little bit closer. Then if we want to show the third energy level, we would move a little bit further away from the nucleus and start putting in electrons. And again, the first 2 of the energy level are a little closer than the rest. So there's one that's closer, and there's one that's a little bit closer. And then there can be 6 a little bit further away. So I drew 6 a little bit further out. And that gets us to our 18 total, and that's as far as we're going to go. In reality, this third energy level is able to hold 10 more electrons that I did not draw here. But they would be a little bit further out than these 6 electrons as well. But again, this is as far as we're going to go for now. If you take more chemistry, you'll learn how to go beyond that. All right? And even a couple of the videos you'll watch will show you that. But you're not going to be responsible for going more than 18 electrons. And then lastly, I just want to review that if we draw the atoms in the various groups, like in group 1, and we show their electrons, it clearly shows us why all these atoms or these elements are in group 1. So if we draw hydrogen, there's our nucleus, and hydrogen only has 1 electron. So we put it right there, and it's in the first energy level, and that's its outermost electron. If we do lithium, it has 3 electrons. So first 2 go in the first energy level, then the next one goes in the second energy level. So it's the first electron in the second energy level. But again, it's out there by itself. So you can see a very similar pattern. They have 1 electron entered by themselves. And then the same holds true for sodium. Sodium has 11 electrons. 2 are in the first energy level, and then 8 total in the second energy level for 10. And then 1 more to make 11, and that 1 more is out by itself in the third energy level. So the reason these 3 are in group 1 is they all have 1 electron in their outer energy level. And of course, they will make positive ions by losing that electron or donating that electron to some other atom. So when hydrogen loses that electron, it becomes a hydrogen ion. When lithium loses that electron, it becomes a lithium plus 1 ion. And the same with sodium. It loses that 1 electron and becomes a sodium plus 1 ion. So they lose those electrons to have a filled outer energy level, or it makes them more stable. So in the activity or assignment you're going to do for today, you're going to do something very similar to this. You're going to simply review electron configuration at a very basic level and draw some structures similar to these. Then we'll take a look at a little bit more detail on exactly how these electrons arrange themselves and in what area or space around the nucleus. Okay, good luck. If you have questions, be sure to post them.